Hey guys, this is lesson 4, which is 5.5 in the book. We are going to talk about all the ways to factor. So this is kind of a long lesson. We won't get it completely all the way through, but we're going to focus on 4 of the techniques of factoring. And so if you'll go through here, like the first technique is GCF. So I'm going to go in order, but to help you remember, I'm going to use this hand here. We're going to call the sum GCF. So when a lot of countries like count, instead of using like their this finger for one, they use their thumb. So we're going to, you always start with the GCF. So that's the very first one. So let's go down here and we're going to factor out the GCF or find the GCF in each one of these, and then we're going to move on to factoring the GCF. So GCF is the greatest common factor. So what is a factor of this or this? So think smaller or at most one of these numbers. So what is a number that goes into both 24 and 36? So what is that biggest one? So it is going to be 12. Okay, so try it on these two. These two are a little bit different. Let's try that. Okay, so this is your answer for number, the second one. So we have 12 and 8 to begin with. So what is the biggest number that goes into 12 and 8, which is 4? Okay, so now let's move on to our x's. So we have x to the 5th and x squared. You are going to take, to find the GCF, you are going to take the smallest of the two. So that's where that x squared comes in. Same thing. Y to the 3rd, y to the 4th. We're going to take the smallest, which is y to the 3rd. Okay, this one, we have 5x and we have 6. Nothing will go in to either of those. So the only thing that goes in both this and this as a whole is x minus 7. So it's a little bit different way than maybe what you're used to, but that's finding the GCF. So I want you to use those techniques to go ahead and factor each of these polynomials. Okay, so this one, they had a 4 in common, and then I took out the smallest of both of them, so that's where I got that. And then if I take out a 4, 12 divided by 4 is 3. If I have 5 x's and I took out 2, I have 3 left over. If I have 3 y's and took out 2, I have 1 left over. So that's that thought process there. So this is my final answer. If you look at this whole thing, what it has in common is an x minus 7. So I'm going to factor that out. And then I'm going to ask myself, okay, well, what's left of this 5x? What's left of this one? Minus 6. So that's how I got that one. And same thing here. It's implied that there's a 1 there. Please do not forget that. So if you factor out x plus 5, you're still going to have that 1 there. Okay, so now we're going to factor by grouping. And this is just another technique of like what we have been doing. So if you'll recall, factor by grouping is we're going to group the first 2 and the last 2, and then factor out a GCF of each. So this one would be, I can factor out an x squared. So I have x plus 1. And over here, I can factor out a 4 and have x plus 1. So now I'm going to factor out an x plus 1, and I have x squared plus 4. So go ahead and try this one. Okay, so I put my steps down here. So factored out a GCF here, and factor out a GCF for the second 2, and then end up with this for my answer. Okay, so that is what you do first. When you come to factor problems, you factor out GCF, you deal with all the GCF first. Okay, now we're going to talk about the difference of squares. So we just talked about this in the former video or the last lesson. And so this is going to be that second finger. So it's going to be that squares or the pointer finger. Okay, So let's go ahead and just kind of fall back on what we know. So we're going to go, we went in the other video, we went from here to here. Now we're going backwards. So I'm going to take the square root of this, square root of this, one is plus and one is minus. Like that. Okay, see if you can do these other three. Okay, so on this one, this should have been your first step. But notice I can do the same thing. So I can take the square root of this, the square root of this, and I have a minus. Over here, I can't do it because I have a plus. So I just broke that down one more step. Same thing with this one. So I ended up with this, and I could break this down even more. So here I put the GCF, and same thing, I could break that down even more. Okay, so now our third step is going to be perfect square trinomial. So it's going to be our third finger because 3 tri and squares is 2, and the first thing that we do is a GCF. So I'm just keeping up with the hand. Okay, so in the last video, we went from, you know, like this to this, but now we're going to go the other way. So like I said, these are as easy to spot, but notice if you can take a square root of each of those and just kind of play around with it. So that's a minus. And I just kind of go ahead and write it out, and I'll explain in a second. And so if I did like -6 minus 6, negative 6x minus 6x, that's going to give me negative 12x. So notice I doubled that. So that meets the criteria. So my final answer is 2x minus 3 squared. So I think it's just a matter of like training your brain to see it. Like this one is going to be 10x plus, because it's 11y squared. Go ahead and try these two. Okay, so this one I factored out a 2 first, and then I found that the perfect square trinomial. I want you to see that there's a perfect square trinomial here. So this is x plus 5 squared minus z squared. So sometimes you'll see that, and you're able to take it a little bit further that way. Okay. So the final one that we're going to talk about today, we're not going to talk about the fifth one, is the sum or difference of cubes. So we are going to add that. We're going to add it to this finger because, again, we always have two terms there. So I'm going to put cubes. Okay, so we always have two terms, so it's going to be that second finger there. And so I want to talk about your teachers in the past have probably talked about SOAP. So what SOAP is, okay, so your teachers in the past have probably talked to you about SOAP, and SOAP stands for same, opposite, always positive. And so I'll explain it here in a second. Okay, so this sign stands for same in SOAP. This is opposite, and this is always positive. Okay, so same, opposite, always positive. Okay, so for this one, notice we went from a cubed to, oh shoot, I forgot, a plus b, sorry. So that's the first part of it. So we went from a cubed to a plus b. So I'm going to take the cubed root of this and the cubed root of this. And this is plus or minus. Okay, so I have 2x minus 3 because it's going to be the same. Let me redo this. Okay, so it helps when I write the equation down right. So this is our original problem. So when you go from here to here, it's always whatever this sign is. So that's why I took the cubed root of 8x cubed and the cubed root of 27 of 2x minus 3. And then I'm going to have 3 things to fill in, but I'm always going to do the signs first. So this is going to be opposite. So if this is minus, this is plus, and this is always going to be positive. So notice something else. I'm going from a to a squared. So I'm going to look at this and go from a and square it. So it's going to be 4x squared. I'm also going to do the same thing with the 3 and have that be my last term. My middle term is going to be these two multiplied together. Do not worry about the sign. So all I'm going to write down is 6x. And then I'm done. So go ahead and try to do this one on your own. Okay, so the first thing I noticed about this one is I couldn't take the cubed root of both of it. So I factored out at 5, and I got that. When you take the cubed root of like x to the 6th, you're dividing by 3. So that's where I got squared and then minus 2. So I took this and squared it. I took this and squared it. And my middle term was those two multiplied together. Okay, so this is our last one. We are going to do difference of squares, and then we're going to do difference of cubes. So go ahead and see if you can do that. Okay, so this whole thing is my answer. So I broke this up by doing difference of squares. And this, notice my signs. So same, opposite, always positive. And this one I broke into the difference of cubes. So same, opposite, always positive. So that is it. We are done.